Okay.
All right, so good morning, or I guess I should say good day, everybody. Welcome to another ONOS TST meeting. This is a public and recorded meeting that will be posted on YouTube. So today, the principal item on the agenda is to provide an update on the µONOS, specifically on the onos-config subsystem. And so we have a series of updates and demos for this. So I'm going to pass it on to you guys. We're going to start with integration testing improvements, and I assume that will be you, Ray, and Adib, right?
Yep. I'll do the slide, and then Adib has a demo at the end.
Great.
We're going to demos for the end to make this part quicker.
Perfect.
So since the last time we got together, we've invested some more effort into improving our integration testing framework. I should have put up on here that Jordan also did a bunch of work on the ON.It tool itself, so we can do things like fetching logs directly out of the cluster, and it has things like command line tab recognition of test names and stuff like that. So the tool is just really convenient for running stuff inside of Kubernetes. We added an integration test job on Travis. Currently, it only runs on merge commits. The reason it only runs on merges is because it takes between 10 and 12 minutes, and we thought that was probably too long for something that was going to be run for every check-in. So it's not run on PRs, but it is run on accepted PRs. Andrea added a client-side subscription integration test. So basically what this is a mock-up / demonstration of what an application doing a subscription would look like. That's actually run now as part of CI. He'll give a demo on that later. I added one with a little help from Andrea as well about transaction rollback testing. Similarly, the idea is that this would be model code that someone writing an app can see how they would do rollback. And it is not checked in yet, but I'll give a little demo of what it looks like later. And Adib, with some help from some other folks, put together an integration test to allow us to drive Stratum through onos-config using ON.It. This is really cool. This allows you to basically simulate an entire Stratum-based little network through Kubernetes. So once that is accepted and completely stable, we'll add that as part of the integration test job as well. Okay, Thomas, back to you.
Great. Okay, so next let's talk about error channels for the GNMI. Do you want to cover that, Andrea?
Yeah, that's me. So since the last update, we actually introduced an error mechanism to enable handling of errors, meaning really that before we just were logging them, but not taking any action. So for example, if a failed configuration, a wrong configuration was sent to onos-config, it was sent down to the device. If the device rejected it, we didn't have any capability to actually get the response from the device and act on it, for example, doing rollback. So now we introduce these two channels. The one is a specific for the request. The other one is general for a device. So the first one, general for the device, is always active. It listens for device-wide operations, disconnection, connection, capabilities, initial configuration set, basically. That is one for each device. The other one is specific for the set, and the listening for that is a blocking listen that is active only when a set request is made. So when a set request is made, then we actively block listening on the channel with a certain timeout, waiting for a response from the device. If the response is positive, we take no action, meaning that everything is okay. If the response is negative, we actually handle further the error. So can you go to the next one? Tom?
Okay, thanks. All right, and
So
you want to take this also?
Yes, exactly. So basically taking that action on a device, one example of that is the rollback. So we introduce capabilities in onos-config core to do rollback of the configuration of a given device, meaning that before we were removing the change ID from the configuration store in a device, but now we're also computing the delta against the previous value of the path that was rolled back, and that is each path that is comprised into a change, and that delta is sent down to the device, meaning that then the device actually receives a GNMI set request with the previous value to the change of that we want to roll back. So this rollback method is then used when an error is received on a set request. If that set request is part of a wider network change, that network change has to be rolled back as a whole, meaning that every device in the change needs to be brought back to the state before it was changed by this network change that failed. So we compute the delta per each device on each path with the rollback value and the previous value, and then we send down to each device the value, the updated set of values, in order to roll back that change that was written by the failed network configuration change. I'll do a demo of this later.
This is great. All right. So the next item, this was actually done a while back, but we haven't provided an update on this because Sean was out of the office. So Sean, do you want to take this?
Thanks, Thomas. Yeah, so this is about, can you hear me okay?
Yes.
Yep.
Yeah, so this is about the model plugin. So basically, I think about a month ago, we had a discussion about how we would use YGOT, the Yang Go tools. And somebody suggested, I think it was Brian, that we create a plugin for our Go module, and this is what we ended up doing. So why are models needed? Models really are for set operations. So basically, when a set is executed now, there's the per device config is checked against the model for that particular device, right? If, say, for instance, values are out of range or a wrong data type, or lists are out of range, or something doesn't meet the Yang model, you'll get an error and it will go back. So basically, the idea is that it prevents sending wrong configuration down to the device. That's the ultimate goal here, is not to be sending erroneous data down to a device, to stop it at the very top level, which is the front face of onos-config. So just a word about the plugins then. So how do we extend onos-config? So what we did was use a plugin approach rather than a separate module. It maybe would have been possible to write a separate ONOS module and have it loaded up through Kubernetes or whatever, but we decided on the plugin approach, which is effectively a shared library object. I'm getting a bit of echo. Maybe somebody should mute if there's feedback coming through your system. Anyway, at the moment, these modules are loaded optionally. They can be loaded at startup or at runtime. If they're present at startup, then the configuration that's in there when the system starts up is validated there and then, and whatever it has loaded from the stores basically is checked against those Yang models. Another factor that isn't in there yet, but the plan is that basically when you actually connect to a device and the device gives you its capabilities, the capabilities should be checked against the model's capabilities. And if there's a mismatch, it means that basically either maybe the device has been upgraded in the field, or somebody's trying to connect a device that's actually the wrong one for the model that's there. So another layer of protection to save sending erroneous data down to a device. There's a model registry, and basically that gives every component inside onos-config access to the model types and schema data, and for validation and all of that kind of stuff. And also there's an admin gRPC interface to onos-config, and now the metadata, the compiled Yang schema, is effectively available through this gRPC, and this might be useful if, for instance, you had a model-driven client or a model-driven GUI, for instance. So, you know, there's a fair bit of flexibility, and you know, part of the reason for keeping it like it is so that customers could come along and build their own model plugins without having to tamper around with the core functionality of onos-config. There's an explanatory document on the whole thing at that document, modelplugin.md, which has more information. So, Thomas, I have a demo as well, and I can wait until the other guys go if we want to do them in that order.
Yeah, sure. That sounds good. Also, a quick question. So you're currently adding validation, right, based on the model stuff?
Yeah, that's correct. Yeah, and I'll give a demo of that later.
Oh, perfect. Awesome. All right. So let's just go in the order that we have the demos listed, if that's all right. So I'm gonna pass control to Adib. Do you need it, or should I give it to the conference room?
I think Adib's going to do it on his laptop.
Yes, you can. If you make me presenter, so I will present.
Done?
And can you hear Adib?
Yes, we can.
Okay, good.
All right. Can you see my screen now, right?
Correct. Yes.
All right. Okay. So I'm going to show you a demo of how we can create a mininet network of Stratum switches in ON.It. So I already updated the documents. You can read the commands that we added to the ON.It. So actually, we have a new command, ON.It add network. So we can provide a name to the network, and also we can pass a set of mininet options. So for emulating a mininet network. So the options are exactly the same as mininet options. Currently, we support two types of network topologies, a single node network topology and also a linear network topology. Our plan is to add more network topologies, for example, tree, or even a custom network topology. It means that if we define a network topology in a Python file, we should be able to pass it as an argument to the ON.It, and the ON.It should be able to add the devices to the onos-config, and they create the network. So here is my screen. In the left side, I already started the ON.It cluster. You can see the onos-config, atomics, and RAF. So I want to add a network to the ON.It. So here I have a command, ON.It add network. I gave a name, Stratum1. So and I passed the arguments topolinear with two nodes. It means that I would like to create a network, a linear network topology with two nodes. So if I execute this command, so the pod will be created in the left side. You will see that the pod is created, the container is running. So, and then we reconfigure the onos-config node. It means that for each node, we create a service, we expose a gRPC port. So if I run get svc here, so you see two devices have been added as a service to the list of Kubernetes services. So Stratum1, and the name of each device is the first part, the prefix is the network ID, and the suffix is the switch ID. So Stratum1 is the network ID, and S0 is the switch 1. Stratum1, S1 is the switch 2. And if you look at the ports that have been exposed, 50,001 is for the switch 0, 50,002 is for the second switch. So it means that we create a pod, the Stratum1 is the pod, and for each device we create a service and we expose a port. So later on we will be able to communicate with each of the devices separately. So also if you go to the onos-config docker. So this is the onos-config docker. If I run onos devices list, so these two devices have been added to the list of onos-config. So so that's part of the reconfiguring onos-config nodes. It means that these devices should be added to the strat. So if I remove this network stratum 1, so the network will be shutting down. The list of devices will be updated. There is no device. The resources have been released. The services have been deleted, and also the pod is terminating. The stratum pod is terminating, and it will be gone in a few minutes. So this is the demo. The next step that I'm working on, I want to add integration test that we can test the stratum devices. So now we have the base infrastructure to communicate with the stratum devices for testing purposes. Any questions? Any comments?
No, this is excellent.
Yeah, it really is. Where are you getting the stratum image from?
It's in a private Docker hub now. So I think it will be released when the project is published. So
Travis probably can't see it then. Probably can't release this until
until it's open source.
Stratum's open. Yeah.
So
That's
now, whenever we want to run this, we need to load the image manually into the client cluster.
Gotcha. Okay.
So if you have access, I assume that all of the ONF people have access to that Docker repository, so they can add it to the client cluster. But it's not part of the makefile now until the project becomes open.
Okay. That's what I thought.
This will be open sourced and publicly available by ONF Connect. So.
Oh, okay.
Yeah.
Good.
This is excellent work, Hadid.
Thank you. All right, I'm done. So.
All right. Yeah. So who do we want to go next? Rollback. Andrea, do you want to go next?
Sure, I can do that. Let me take presentation rights.
Yep, I made you presenter.
I should bring up the thing.
Okay. Can you guys see my screen?
Yes, we can.
Okay, perfect. So here on the left, on the right, sorry, I have a running instance of onos-config running locally just for.
Hold on a second. There we go. Thank you.
Okay.
Unmuted conference room, Menlo. Go ahead.
Okay. So I had to reset my simulators. So here on the right, I have a list of onos-config that shows this is just running the whole element, the whole thing, and what I will show is that why is it not connecting? Interesting. Sorry. Bring down the emulators and bring them up again. Just give me 1 second.
Yeah, no worries.
It's not connecting for some reason. There we go. Okay, much better. So I have the 3 emulators connected. Shows the capabilities. It does show that it loads the initial configuration, meaning that whatever configuration is in the onos-config store, it gets loaded, and that's why if we execute a get against onos-config for that device, we actually see that the value for the clock is Europe Dublin. So and this is both on localhost 1, which is what we are targeting right now, but also if we get localhost 2, which is what I'm doing here, you guys will see that it's again Europe Dublin. So the rollback that I want to show is done with this command. So what this command does is that it tries to do a set request to onos-config to populate 4 elements on the different devices that we have. So it populates the clock to be Europe Berlin on localhost 1, and the clock to be Europe Paris on localhost 2. On localhost 1, it also sets the MOTD banner to this is a new demo device. And also there is tries to set a wrong path with a foobar name in here. So if we try to do this, I'll do it down here. What we'll do is that it will fail, and it will say, it will report the fact that it failed because it could not find the path in the tree beyond the authentication config because it couldn't find the foobar name because that's the wrong name. So this is an error that gets reported by the device. So if we go take a look at what we're doing here in onos-config, I'll make this a little bit bigger so you guys can see it better. So what happens is that we are trying to set a configuration here for path for device localhost number 2, but we get an error. So what we decide to do is that we roll back the last change. So we bring back the state of things to the state of what it was before. So if we go back and do a check of this, if we do this one, you will see that again on localhost 2, it did not change to Europe Paris, but it stayed in Europe Dublin because we rolled back the configuration. So for example, here we're trying to get the open-config time zone name for each device because we changed it on both, in particular in this case for localhost 2, and we're rolling it back. And we're just saying, no, forget it. We don't want to do this. Just roll it back to the previous state of things. And that is done again when the error is there, or you can actually do it through the admin interface. And for that, I'll let Ray show you how it's done.
Perfect. And just to clarify, so clearly right now you were showing a wrong path, right? Which is, and the device rejects that, which should always do anyway. But I think after we have the model validation, errors like these would get preempted at the northbound, right? But there could be potentially other errors that pass the initial validation, which the device still rejects.
Precisely. Yeah. It's funny that you mentioned that. So if I show you the command to which I run onos-config to, which is this, it does not load any model plugin because loading the model plugin would actually prevent me to show the rollback.
Oh, okay. It would already do that. That's right. That's right.
Yeah. So basically, when loading Sean's model plugins, what we do is we get this error even before sending it down to the device. So we don't send it down at all. Being that we still might need to roll back some changes that happen on other devices because again, we will get this error here. Meaning that it's probably going to be in the it is in a very similar format, but that format is going to be issued by onos-config and not the device itself.
Right.
So instead of hitting the problem by sending the whole thing down to the device, we will hit the problem against onos-config, meaning that localhost 2 cannot be configured for that reason, but we will still need to roll back on localhost 1. So we will do that based on the model plugin check.
If there's an error during the rollback phase, is that just propagated up and then the thing is left in an unknown state, or how's that managed?
That's a very good point. I have not implemented that yet, meaning that if there is an error during the rollback, at the moment it does nothing, meaning that it leaves the device to a state which is the state after the rollback. meaning that we did apply change B after change A. We did try to roll back change B. There was some failure. So we leave the configuration in onos-config to change A, and the device might be in an inconsistent state. That's definitely something that we will be working on. I know exactly where to put it. There is a log.info log error there at the moment that just logs the fact that we got an error. I also don't want to get into a chicken and egg problem. What we might want to do is that we might retry at least once. That's my take. To roll back to the state of the configuration that was prior to the rollback. After the rollback. Because at some point that configuration worked. Because if we roll back any configuration that it is saved in onos-config, it means that it worked on the device, because otherwise it would have been not saved, meaning rollback. So we know that up to change A, it was working. So when rolling back to change A, if there was an error, it might have been like device disconnected or some other reason. But at least we know that at some point stuff on A worked. So we could try to reapply the whole set of changes up to A, because there might have been an inconsistency in the timing or like network failure time, like.
So you're looking at this as an eventual consistency issue where, look, here's my intended state that I know last worked. I'm going to keep retrying, maybe with back off, maybe a certain time, whatever, until it gets to that state. And once I hit some sort of crossover, I'm going to complete fail, but that's a different issue.
Right.
Yes.
Is that kind of the philosophy you're taking?
That would be my. We didn't discuss this yet entirely. We just did this a few days ago. So that would be my preference to do. Basically a iteration on retries for a certain time, or a certain amount of retries that has still yet to be defined. And if at some point that completely fails, we might want to roll back to an initial configuration, or like completely blitz the configuration for the device, maybe poll what the device has and try to do some matching and to the best we can do.
I mean, another possibility is to just have some kind of an audit mechanism that allows us, a user understand what broke and how they can manually intervene and fix it.
Well, that kind of raises the next question. When we're in a rollback fail state, are any future are new changes allowed, or are they denied or queued?
No, they wouldn't be allowed. I think the idea here is that clearly this is a corner case scenario, but it's one that we need to take care of nonetheless. I think there might potentially be multiple viable strategies for trying to remedy the situation, and those we might actually allow the deployment to select between between the preferred strategy. Andrea enumerated a number of them. There could be others. So clearly, this is a kind of a corner case that we need to be able to have a way.
I mean, I agree it's a corner case, but it's one of these things that, look, if everything's working great, everybody's happy. But the minute something breaks,
I'm not suggesting we don't take care of it. I'm just suggesting there might be multiple ways out of that corner, and we may
And at Sean's point, when you're in that failed state, maybe there is some level of user that has to have authority to go in there and make some changes regardless of state. I agree. We're hoping it's a 1% case, but it's the 1% that'll bring down the World Cup.
Oh yeah, no, I get it. Completely understand and agree.
Okay.
One other word on this subject of the need for a rollback. I mean, the reason Andrea is doing this is because the gRPC interface, or GNMI, doesn't really support any kind of rollback or transaction in the way that netconf did. So I mean, it's trying to bring rollback functionality to a device that doesn't have rollback effectively. Whether whether devices will have rollback through some side channel or alternative interface in a particular implementation. That's something that can be handled, as these things kind of, become more mature.
Right.
But for the moment, this is to support devices that don't have a rollback capability.
Right. So, but
yeah,
just to be
rollback on
clear,
a network's always interesting because a network is an acid, right? The minute a switch is on the network, it's communicating to its neighbor potentially, and so there's some transient state that makes rollback odd in terms of networks.
So just to be clear also, the GNMI has transactional semantics with respect to a single set request. So the targets that implement gRPC are expected to commit everything or nothing as part of the single set request. So there is transactionality within the bounds of a single device implicitly. But what we're talking about here, be able to extend it across multiple devices, and this is where the value of the onos-config comes in. There needs to be an implicit transaction between all of the targets that are involved in a set request from the northbound, so that there's the implicit rollback. If something fails among the operations within a single set operation, everything needs to be returned back to where it was, kind of implicitly. But there's also explicit rollback, and that's what Sean was talking about, that's available through our administrative interface, and that is to be engaged after everything was successful. Let's say we put
is the transaction semantics, you said a single thing though, it's not a two-phase transaction, correct?
Well, from a standpoint,
it's not in the sense that netconf was. I mean, netconf basically has, the concept of standby and running, down to the very level of the device itself, and so that's what I would consider a two-phase commit. That kind of functionality isn't there for gRPC.
So what we're trying to implement is not really a transaction over multiple devices. It really is saying, look, I'm going to push a config, and if that over to multiple devices, and if one of those devices fails, I'm going to try to push an old config. So it's not a rollback per se.
No, we have rollback as well, David. We have full rollback as well, that you can go back to a previous network.
That's the explicit one, right? Because let's say, assume we pushed a change, everything went fine, but we don't like it. So that the explicit rollback that's done through administrative interface basically composes a sort of an inverse change to return everything to the previous state of the network. But it's really explicitly another change that returns things to back where they were. The implicit rollback, which is done as part of, let's say we have three devices in a set operation, right? The first, and we apply them, let's say all of them, try to do all of them at the same time. One of them has committed everything fine. One of them hasn't started committing anything yet. And one of them encountered a failure somewhere in between. So we shouldn't, so we need to, the one that encountered failure should be back to normal, because the agreements are that if it failed, it needs to be back to the previous configuration. It's the first one that committed everything fine that we need to return back to where it was before in order to have this sort of a implicit rollback. And the last one we don't
understood. I guess, when I talk about two-phase commit over multiple targets, I think I do a prepare phase on each of them, which each device has accepted and said, yes, I'm going to make this happen. Everything's good, resources allocated, everything. And I do that to all my devices. And then I go back and do a commit to all my devices. Yeah. And that's kind of what I see as a two-phase commit. What we're talking about is I'm doing multiple independent changes to devices, and if a device fails, that device may roll back. That one device may roll back automatically, but it's then up to me to make sure the other devices are reconfigured back to their previous state.
Correct, and that's basically what we'll be doing, but without the assist of doing the pre-commit. because gRPC doesn't offer that.
Yeah, it's just, I think we have to be careful here because we're not really doing a transaction, right? We're reverting, if you will, the commit. But again, that could fail, and it's just like we're pushing a new config.
Understood. But the idea is to give outwards appearance and behavior of a transaction underneath.
Yeah, I guess I understand that. And I think that's a valid goal. I guess I'm concerned that when you try to give an appearance of something that you actually can't guarantee, that may cause confusion, again, in some corner cases, but may cause confusion.
Perhaps.
Okay, thanks. Don't rant it enough.
Okay. So let's pass control over to Menlo Park and raise.
Thomas, give it to my laptop, please. I have everything set up there.
Got it. My bad. You got it.
All right. So, why is it not showing? That's the wrong screen. That's Menlo's screen. Why is that? That is very strange. Okay. There we go. All right. Sorry about that. So I'm going to show two things. One is pretty quick, but I think pretty interesting. And then the other will be just a bit of a code walkthrough to something that is similar to what Andrea showed you from the command line. I'm going to show you what it looks like in code. So if you go to the ONOS project GitHub page, you'll see we have our fun little badges down at the bottom. And there's one here for build passing that shows the status of Travis. And so if you do a click on that, it shows you basically the last few Travis jobs. So you now see we have two that run as part of merge commits now. One is the normal tests one that we've been running for a while. That's unit tests plus coverage. We have a new one called integration tests. And what this does is this runs the set of integration tests. You can see there's a yay, we're happy down here at the bottom. It's currently only 2 tests. The idea is that it'll be all of them as they get added. Like I said, this takes a while to run because bringing up the Kubernetes environment is pretty expensive. This is running as part of Kind on a Travis VM. Travis is pretty slow, and so this whole thing takes on the order of 12 minutes. So that's why we only run it as a merge commit. The idea behind this is that this will catch the kinds of errors that you can only see when you're running the thing for real inside of an environment with devices. In this case, the devices are simulated. So that badge will turn red if the integration tests get broken and then someone knows about it and can go jump on it. So the other thing I'm going to show is if you were following what, let me try to make this a little bigger. You're following what Andrea was showing with his CLI rollback example. This is going to look very similar, except this is kind of what the code on the client side might look like. I actually wanted to show this code running. It doesn't quite work yet. We have a bug that Sean, Andrea, and I are trying to figure out what's going on. But essentially, this is going to look very similar to what Andrea was showing. I've decided to set 2 of these banner paths. The way that the code works is these things are passed in these device path arrays. And so this code up here is just creating those things. Not terribly interesting. This bit here is kind of interesting, the register test. So right now you can type make integration and it will run all the integration tests. And that's what that job I just showed you does. What this code that I just highlighted here is doing is this is actually registering with ONIT. And you'll see here we have this special thing called integration tests. That's what make integration runs. So essentially when you're writing a new test, if you add this little bit of code to your init method, it will make it available to other people to run through the ONIT command line. This is just some various stuff. Anyway, this is kind of the meat of it. GNMI client is something that you'll use all over the place on the client side. Basically, we have 2 clients that we export. One is the GNMI one, which is very similar to what that long command line that Andrea was typing, that's all encapsulated in this structure here. We also have something called an admin client, which is right here. Admin client is essentially stuff that onos-config has added that's not part of the GNMI sort of universe. Right now, what I'm going to use it for is actually rolling back the change I made. So when I do the set operation to create a new change set, I get back a change ID. And what I can do is through this admin client, I can tell the onos-config, hey, I didn't like this change, I want you to unwind it. And it's, as you can see from the client side, it's actually very simple. There's way more code down here checking that it worked than there is to actually do the rollback. So that's kind of neat. And what the test is basically doing is, you know, what you'd imagine. It does a set of some known values, fetches that they're correct, rolls them back, and then checks that they got rolled back correctly. So anyway, this is an example of client-side admin client access. Anyone have any questions?
That's great.
All right, Thomas, I'll turn it back to you.
Right.
All right, and I think last version is the demo from Sean on model plugins. Sean, I'll pass you the token.
Yeah. Okay. Let's see if I can share this. Okay. Can you see my screen there?
Yes.
Yes.
Yeah. Okay. So I just have a few things running that I just wanted to show. So this is about model plugins, and so I'd started onos-config earlier, and you can see I've loaded these two model plugins, right? So I have a third one as well that I'll load in a minute, but what I wanted to show here is the loading these model plugins at startup, and as you can see, then any device that has its configuration, then with those plugins or with those models is validated against the model. So basically it goes in to all of the Yang and validates that nothing is illegal, that it's valid as far as the Yang is concerned. And so that's it, it goes off and it runs onos-config. So with the onos client, there's a models command, and if you list the models, what it does is it basically shows you the models that are loaded, the Yangs that comprise that model, and then I've added this where basically it shows you the containers and lists of that model. So basically that's a kind of like the top level objects, container 1A, list 2A, and so on like this. It's not showing the leaves here. And device basically is just a representation of the top level, you know, so there are actually leaves at the top level, not under any particular container. I have two models loaded here, version 1 and version 2 of this, and you can see the date is different between the two. And the difference is that in this later version of the model, a new container was added, so container 2C, and that's really the difference between them. And so basically, you know, if you were connecting, depending on what version your device is at, you would be using one or other of these models. So I was just going to load the other model plugin that I have. It is device sim version 1. Okay, so this is for my device simulator, and it loads it from the shared object library. And now when I go model list, basically I can see that's a much bigger model. There's like there's 4 Yang files, all of the open-config stuff, and here's all of the containers and lists and everything belonging to that. So there's quite an amount of information, and the names here basically are what YGOT gives us. So it takes each of those Yang files and all of their augments and all of their deviations and all of this kind of stuff, and basically arranges them into a hierarchy of objects that basically we can validate a configuration against. I was going to let me see.
Sean, before you show that, maybe kind of going back to the versioning issue, can I take a version 1 Yang and push it to a version 2, a device that supports version 2 of that Yang? You know, if there are forward compatible changes, that's kind of what I'm trying to get at.
Yeah. So the idea is that if you wanted to upgrade your device, so maybe there's you have the model or you have the configuration for your device, and it's stored in onos-config against model version 1. Then I think there would have to be something would come along, and it's not clear whether it's internal or external, and maybe it'll be part of the model plugin actually that tells you how to upgrade the configuration from version 1.0 to 2.0, and then, you know, maybe internal or external to onos-config, you would decide, I want to upgrade my device now. So you have a configuration for version 1 that's all synchronized and everything's working. You send the command, the device reboots, it comes back up, it says, no, my version is version 2.0. He connects to the version 2.0 configuration, and the whole thing is in sync. And basically, this is how we envisage that whole upgrade scenario to go. And but I wouldn't think it would be valid to be sending version 1 configuration down to a version 2 device unless a customer specifically wanted that. But I would see in that case, David, that really you would have a version 1.0.1 that has the same, you know, well, I think there has to be a model per each configuration, and it has to fit here.
Essentially drain all requests on version 1, upgrade, and then version 2 requests are accepted. All right, cool, thank you.
Yeah. Okay, so basically I wanted to show the now that the thing is loaded, I wanted to show the Yang file. So this is just a quick peek of that simple Yang file. It's pretty simple. Container 1A, you know, container 2A inside it, and then a number of leafs, right? So basically, I'm going concentrating on leaf 2B, okay? And as you can see here, it's a decimal value, and basically, it's got a range, you know, from 0.001 up to 2.0. So what I was going to do is I was going to get the configuration. I think it's this one. Yeah, so basically I was going to do a GNMI get against this object. So let me see, device 1, container 1A, container 2A, and then leaf 2B. So basically the current value for it is this floating point value here at the moment. Now I was going to do a set against it, and I was going to give us a value of 0.891, and this works because it's in range. You can see the set, it goes ahead. If I do the get, again, the value is changed. Now I was going to do a set with 2.891, right? So basically this is over the limit, and so I get the response here from through GNMI, basically, that the decimal value is out of range. It's telling you the wrong value. It's telling you what the leaf was, and so basically now you can go back to your configuration and see what the problem was. So the idea here really is that, you know, you shouldn't be allowing any changes that aren't valid by Yang, and when you have the model plugins loaded, that kind of enforcing is there for the set request.
Right, and when this impacts the rollback scenario, is that basically kind of narrows the window for when we would need to engage the rollback. The rollback,
absolutely.
Yeah, the implicit rollback would only come in environments where it passes the Yang validation, but for some environmental reasons, the device is unable to take it.
Exactly, yeah. I mean, there's always going to be a risk of maybe something is broken on the device. But here we can do the maximum amount to prevent wrong configuration going into it. Because, say for instance, if we allowed wrong configuration to go into the onos-config data store, there's no recovery mechanism on earth that could try and recover that situation if the device was never going to accept a value that high. So accurately having accurate models, I think, is a very important part. And the other part of having accurate models is that you could drive, for instance, a GUI through have a model-driven GUI effectively, and that's really what I'm kind of getting at here. Is here I'm only showing the objects and the lists, but behind it there's a whole structure of leaves and ranges and leaf lists and all that kind of stuff as well, and that can be represented in say a JSON format and sent up to a GUI that could be driven off a model for this kind of thing as well. So it's really bringing it back up to the user interface and having that sort of a protection there all the way up.
Yeah, this is great. I think one of
okay, that's all I have.
Yep. Well, are there any questions or suggestions or comments from the audience?
So one point is I will be doing a stratum model in the next few days as well, and so this will sort of tie in with the work Adib is doing there in terms of having a model for stratum, and we should be trying to do some sets and validating the config on that as well.
Right. Well, great. So I think one last parting note, at least from my side. I've briefly talked with Carmelo, and we'll be starting to create the ONOS control repository to start bootstrapping the control counterpart subsystem to config. So I'll be on the lookout for that. That should happen within next day or two. Clearly, it'll just be a skeletal structure for right now. But I would like to start placing some of the design collateral, plus also some of the experiments with doing P4 runtime work, similar to what we're seeing here with GNMI. Anyway, that's just a quick note. So that project is going to start lifting off the ground. All right. If there is no further comments, questions, then we can probably call it a day. And the plan is to have another one of these updates 2 weeks from now. All right. Thanks, everybody. Great work.
Thanks, everybody.
All right.
Bye.
Bye-bye.
All right, bye.
Bye, thanks.